Okay, I told you we'd get back to other values of that power, and what we're going to do now is we're going to look at what if you have a negative integer power of x. The binomial expansion only worked for positive integer powers, x plus h to the n had to be 0, 1, 2, 3, 4. But now we've got the quotient rule, we can actually extend this proof a little bit more. So we are looking for the derivative of x to the n, where n is a negative integer power. So what we're going to do is we're going to say, well, we know what negative integers do. They give us the reciprocal of the positive power. So this is the derivative of 1 over x to the m, where m is equal to negative n, or n is equal to negative m. So now let's use the quotient rule. U is equal to 1. Remember I said it's very important you write out u and v every time, or you are going to confuse yourself. The derivative of u is 0 because 1 is a constant. The derivative of v is m times x to the m minus 1 because of the power rule, because m is a positive integer value. So what is the derivative of x to the n? Excuse me, let's clarify that. What is the derivative of 1 over x to the m? Well, using the quotient rule, it is v du x to the m times 0 minus u dv 1 times m x to the m minus 1 divided by v squared. Well, let's do some simplification. This is negative mx to the m minus 1 divided by x to the 2m. My shortcut for exponents is that I'm going to subtract those. So these are just going to be m minus 1 minus 2m. That gives me negative mx to the, well, m minus 1 minus 2m is a negative m minus 1. But one thing I might notice is m and negative n are the same thing. So this equals n x to the n minus 1 works exactly the same. So this comes in a little bit useful. Let's do a quick example. Let's look at y equals x squared plus 3 over 2x. Now, we could use the quotient rule for this, but the other thing that we can do is we can rewrite this as two separate functions, x squared over 2x plus 3 over 2x. And guys, here's the trick. Anytime you see a variable in the bottom of a function and you're talking about finding a derivative, rewrite it as a negative exponent. So what we've got now is that we've got y equals, doing some simplification, 1/2 x plus 3/2 x to the negative 1. And now I can use the power rule. The derivative of this function is 1/2 plus 3/2 times negative x to the negative 2. And this is why I say write it as a power, because otherwise it's hard to use the power rule. The derivative, rewriting this, is equal to 1/2 minus 3 over 2x squared. And the problem is actually find the equation of the tangent line at x equals 1. So I need a couple pieces of information. I need y prime of 1. And looking at this, I can see it's 1/2 minus 3/2, which is negative 1. I need y of 1, and plugging 1 back into the original equation, I realize that's 1 plus 3 divided by 2, which is 4 divided by 2, which is 2. And point slope form of my equation, y minus 2 equals the negative of x minus 1. Because if you don't know point slope form of the equation, super useful, super helpful. No calculations required to find b, the y-intercept. All right, so just a reminder before I close this video out, that trick, always write reciprocals as negative powers if you're planning on taking the derivative, because it just makes life much easier. You can just go straight to, hey, the power rule for a power of -1. So now we have decided that our rule for n integer greater than 0 and less than 0, the derivative of x to the n is nx to the n minus 1.